All right, so now we're ready to talk about domain and range. Our goal for today is I can identify the domain and range of a function. And you can go ahead and pre-rate yourself on that. If you're not sure what that is, then obviously give yourself a 1. And if you're like, yeah, I could do this whole worksheet by myself. Look at that. I've seen this all before. Then give yourself a 3. Okay. So as you can see, the beginning of notes looks very similar to the relations notes, but we add domain and range into it. Okay, so this says, consider the following scenario. Paige is running a lemonade stand. She has enough supplies to make 15 cups of lemonade and sells each cup for $1.25. So first off, what are the variables in the story? So we need to find what X is and Y is. Okay, so I know she's selling lemonade, but I don't know how many cups she's going to sell. It says she can make up to 15 cups, but that doesn't mean she's going to make 15 cups. So my unknown is the number of cups she's going to sell. And since I don't know how many cups she's going to sell, I don't know how much money she's going to make. So my Y is money made. All right, now I'm going to say how the variables are related. As X increases, says the more cups she sells, the more money she makes, so Y increases. Make a table and equation for this story. So we'll put X values, Y values. Okay, so let's go through what she can sell. She can sell 0 cups. She can sell 1, 2, 3, so on and so forth, all the way up to 15 cups. If she sells 0 cups, she makes no money. She has no initial money, so she'll have no money. 1 cup, she'll have $1.25. 2 cups, $2.50. 3 cups, $3.75. All right, so let's write an equation that represents this story. So we have our total amount is equal to, and now we have to think about how we're going to get our total amount here. She's selling cups for $1.25 a piece, so $1.25 times the number of cups she sells. Realize there is no plus or minus an amount because she doesn't have an initial amount. If you're like, where does the 15 come from? That's where we're going to talk about domain in there. Okay, the term domain refers to the list of all possible inputs or X values. So in our equation, we have started to make a list of our domain right here. Okay, we have 0, 1, 2, 3. She cannot sell 1.6 cups or -5 cups. Starts at 0, and then notice it goes up to 15. Okay, so it says which of our variables could be considered the input. That would be our X, always going to be your input. And that is the number of cups sold. So specific to this problem, don't just put X for those. All right, with this in mind, which of the following numbers belong in this particular domain? So can she sell 7 cups? Yes. Can she sell -5 cups? No. Can she sell 2.6 cups? No. How about 3? Yes. 1.25? No. 50? No. Remember, she can't because it says she only has 15 cups total. Can she sell 0? Yes. All right, it says now write the domain of the relation. So this is the part that's new that you really got to listen to. So the domain, if we were saying it out loud in the English language, if you said she can sell anywhere from 0 to 15 cups, I'd be like, okay, I get it. And I wouldn't think decimals are a possibility. But now we have to explain that in math terms. If I write 0 through 15, that includes all decimals in between. So like 1.285432 is a possible answer, and that's not in our domain. So when we're writing our domain and it's a list, what you're going to use is you're going to use a curly bracket. A curly bracket looks like that. You're going to put the lowest amount, which is 0, comma, and then you're going to list all possibilities in between that. So she can sell 1 cup, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, or 15 cups, and then you're going to end it with a curly bracket. Now you might be saying, is there a shortcut way of writing that? There is a shortcut way. Let me show you the acceptable shortcut way. So you can't make up your own shortcut. So you could write curly bracket 0, 1, 2, and these are all comma separating, and then dot, 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 comma. That's taking care of 3 through 14, 15, curly bracket. So showing this is showing that it's all whole numbers in between 0 and 15. I think most people will settle on doing it that way, but I want you to know that that is the shortcut right there. So please also make sure you're writing at least 3 digits right here before you write dot, dot, dot. Okay, next we have the term range. Range refers to all reasonable outputs or Y values in this problem. So we started the list here. This is not the end of the list. It's only the beginning. Which of our variables could be considered the output or the range? So it's our Y value, which is the money made. With that in mind, which of the following numbers belong in our range? So before I start answering this, it's a really good idea to get my range going here because I don't know if 8's in the range. I could figure it out by saying like, okay, 125 times what equals 8 and think about it. Or I can just list my range and then see if 8 is in it. And that's what I think is the better idea. So I'm going to do curly bracket, 0, comma, 1 cup is $1.25. 2 cups is $2.50. 3 cups is $3.75. And I'm going to keep going. Now, all that I'm doing is adding 125 each time. But what I like to do is figure out where I'm going to stop so that I don't just do more work than I have to or not enough work. So I need to figure out how much 15 cups cost. So I need to figure out what 15 times $1.25 is. Yes, you can use a calculator for that. And that is $18.75. So I know once I get to $18.75, I'm going to stop. All right, so $3.75 plus $1.25 is $5. Then $6.25, $7.50. $8.75, $10. $11.25, $12.50. $13.75, $15. $16.25, $17.50, $18.75. And notice I need to stop right there because I already figured out where I'm stopping. Okay, so now I don't need this here anymore. All right, so yes, once again, if you're like, wait, could we have just written 0, comma, 125, comma, 250, comma, dot, 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 comma, 1875? Yes, you could have, but still, I'm looking at this. I don't know if 8's in there, right? Because it's not like physically in my list. If I look at this first list here, I know that 8 is not in there. So 8 is not in my range. 2.5, which is the same thing as 250, is 10. It's right there. -3, absolutely not. I can't make -$3. $1.25, right there. $20. Nope, that's out of my range. $0 is in my range. See? Okay, let's look at another example. And then we will look at graphs. Okay, so this is Joel is working a summer job and he gets paid $250 at the end of each week. At the start of the summer, he had $1,300 in his account. He has 12 weeks to work before he has to go back to college. What are the variables in this story? Okay, so I know he has $1,300 and he's working weekly, and he's going to make $250 per week, right? I just don't know how many weeks he's going to work. He can work up to 12, but I don't know how many he's going to work. So my first unknown is number of weeks worked. All right, now I need Y. So as weeks move on, so after 1 week, 2 weeks, what's changing? Most common mistake is people put down the money he makes, okay? Y is not going to represent the money he makes. Yes, that's what's going to be changing, but Y is going to represent the money in his account because he has $1,300 more than the money he's going to actually make. So I'm going to say amount of money in the account or total money in the account, either one. I'm just going to put money in the account. Okay, how are my variables related? As X increases, so as weeks increase, what's happening to his money? It is increasing, so Y increases. All right, let's make a table and write an equation for this story, X, Y. So he can work 0 weeks. He can say, hey, you know what? I'm solid with my $1,300. I'm not working. 1 week, 2 weeks, 3 weeks, 4 weeks. Now you might be saying like, can he work 2 weeks and 2 days? Notice we set up the problem that he gets paid $250 at the end of the week. So we're telling you you're looking at a whole entire week. He's either working the whole entire week or he's not working at all that week. All right, so how much will be in his account after 0 weeks? $1,300. After 1 week, he'll have $250 more, so that's $1,550. After 2 weeks, he'll have $250 more, so that's $1,800. The next week, $2,050, and then the fourth week, $2,300. I almost said the last week, but that's not the last week. All right, let's write an equation for this. Y equals. So he has that $1,300 no matter what, plus he gets $250 for every week that he works. Once again, you can write Y equals 250X plus 1,300. All right, D says which variable is the domain. So X is going to be our domain. So therefore, that's the number of weeks worked. Write the domain. Okay, so remember, we already said he can only work a whole number, so I can't put like in between 0 and 12. I'm making a list. Lists always go in curly brackets. He can work 0 weeks. He can work 1 week. He can work 2 weeks. And then I'm going to put comma, dot, dot, dot. And then he can work all the way up to 12 weeks. If you wrote out every single number, that is also correct. All right, next, what is
10:19 a.m.
Sorry, that was the time. What variable is the range? The range is your Y variable, which remember is the money in his account. All right, let's write our range here. So he can have $1,300, and you always want to do the smallest number first to the biggest number, okay? Smallest number to the biggest number. So 1,300, and then if I add 250, we said that was 1,550. Add 250, we said that was 1,800. And now I can keep going and keep adding 250 until I've done it up to 12 weeks. Or remember, I can hit dot, dot, dot and figure out how much he'll make after the 12th week. So I'm going to do that. I'm going to do 1,300 plus 250 times 12, and I'm going to figure out how much he made after 12 weeks. I can pop that in my calculator, and that's $4,300. And now I don't need this. All right, write a point. You know what? I should never erase my work. Just leave it there, right? Okay, write a point in which the relation, which is in the relation, and describe what it means. So you can pick any point that you want. I'm just going to pick 0, comma, 1,300. So I'm going to say, what does that mean? It means after 0 weeks, he made $1,300? Absolutely not. That makes no sense, right? So 0 is the start. So I'm going to say he started with $1,300. Now, if I would have picked, let's say, 1,550, I would say after 1 week, he has $1,550 in his account. Right? I wouldn't say he made that much. That's not how much he made. Okay, last thing that we're going to do for today is talk about domain and range for a graph. Okay, domain and range for a graph. And we'll look at this pretty much in every lesson that we see. Okay, so a couple things that you need to know before we start. Okay, if it's a list, you're going to use curly brackets. Okay, so use curly brackets when it's a list of numbers. Now, other things that you might end up using are parentheses or a bracket. You're using these two, a parentheses and or a bracket, when it's not a list. So like if I said list, let's see, let me try to think of an example. The number of, no, that's not going to work either. I'm trying to think of something continuous. Okay, like a pool emptying. How much liquid is left in the pool, right? It doesn't say like there's like 500 gallons and then there's 499. There's all numbers in between, right? So if it's not a list and it's all numbers in between two numbers, you're going to use parentheses and brackets, okay? Parentheses is going to be when the number's not included. So this is when number is not included. Bracket is when the number is included. And copy and paste that. Copy, paste. A number is included. Okay. All right, the last thing that you need to know before we start is that if a graph goes infinitely to the left, that means that it goes on forever and ever and ever and ever and ever towards negatives or negative infinity. We always use a parentheses on negative infinity. Or that's also if it goes forever and ever and ever down, okay, in your range, your y values. If it goes forever and ever and ever to your right or forever and forever and forever up, that means that it goes on to infinite values, and you always use a parentheses on infinity. Okay, let's do these. So domain and range from a graph. So first off, I have to look to say, is this going to be a list or is it all numbers in between two numbers? So if you look, you can see that the lowest x value is -8 and the highest is 6. But is it all x values in between -8 and 6, including decimals? Absolutely not, all right? So this is a list. So what we're going to do is we're going to use a curly bracket, and we're going to say a list of all our x values. So if you look, here's our first x value, which is -8, comma, and you have to go smallest to biggest. We're going to go from the left to the right. -6, then -2. Then we have 2 and 6. That is my domain. Now for my range, I want the lowest my graph goes to the highest my graph goes. So here's the lowest and here's the highest. First, I have to ask myself, is it all values in between those two values? Absolutely not. So I'm going to use curly brackets. So the lowest my graph goes is -7. And then the next lowest is right here, which is -3. The next lowest, +3. And the last one, the highest, is 10. So those are the list of my x and y values. Okay? All right, let's check out the second one. Let's check out B here, okay? Let's do domain first. Domain is x values from the left to the right. This is my lowest x value. This is my highest x value. So the next thing I want to look at it and say, is it all x values in between? Yeah, it is. Look, it's everything, right? So this, you're going to use parentheses and brackets on this answer, Okay, you're going to use parentheses and brackets on this domain. So you're going to write down the lowest your x values go, which are -6, comma. The highest your x values go. As you can see, it's going on forever and ever. So don't say it goes to +6. Since it goes on forever and ever, you're going to say to infinity. All right, now we need to know whether to use a parentheses or a bracket. Okay, so on this -6, as you can see right here, this point, let me delete that for a second. This point is closed. That means it's including that value. So if it's including, I'm going to use a bracket. On infinities, we always use parentheses no matter what. All right, let's do my range. I'm going to do the lowest my graph goes to the highest. These are y values. Y value is height, right? So lowest, highest. All right, is it all values in between? Yes. Right? So I'm using parentheses and brackets. So I'll start with my lowest my y values go, which is -5. If you look on it, it's a closed point, so I'm going to use a bracket, comma. And then I'm going to say the highest my graph goes. The highest my graph goes is an arrow again. So that's infinitely forever and ever and ever. All right, let's try one more, and then you can get started on the homework. Let's do domain first. That's x values, so left to right. Left to right. So first thing I'm going to say is that all x values in between? It is. So this is not curly brackets. This is either parentheses or brackets. All right, so the lowest my x value goes here, the highest it goes here. So I'm going to say in between those two values. So in between -10 and 8, both points are closed. So bracket, bracket. All right, let's do y values. The lowest my graph goes is right here. The highest it goes is here. So it goes from -4 to +2. On -4, people will say, is it including here? Yes. What not including looks like is an open point like this. So this would be not included. This would be included. Okay, so this is closed, bracket. And then this is also obviously closed right here, so bracket. And there's my domains. All right, go ahead and re-rate yourself on how you feel about that is not the correct goal. The goal is identifying the domain and range of a function. This is a copy and pasting error for me, obviously.